Hello everyone, my name is Taemin Jung and I'm a high school rising senior at Faceton Prep School in South Korea. Today, in this honorable time, I would like to discuss my research topic, inhibition to prevent A-beta protein aggregation seen through THT assay and its expectations as a possible treatment of Alzheimer's disease with you. First, I will briefly talk about some background information regarding this research. Then, after an introduction to this topic, I'll present about A-beta aggregation, THT assay, inhibition of A-beta aggregation, therapeutic expectations, and finally the conclusion. Let's start by sharing some background knowledge. After this presentation, you will learn about Alzheimer's disease, the THT assay technique, and the expectations and challenges for Alzheimer's disease treatment. The main reason why I chose this topic is that I became super interested in it after my recent internship at the Yonsei University lab. After some hands-on experiences, I wanted to study more about the relationships between amyloid beta aggregation and Alzheimer's disease. So, what is Alzheimer's disease and the THT assay? Alzheimer's disease, also known as AD, is a progressive neurological disorder marked by cognitive decline, memory loss, and a variety of behavioral abnormalities. The pathogenesis of Alzheimer's disease is characterized by the accumulation of amyloid beta peptides in brain plaques. A-beta peptide aggregation is a complicated process that transforms soluble monomers into insoluble fibrils and plaques, leading to substantial neurotoxicity. Inhibiting A-beta aggregation is a promising strategy to slow Alzheimer's disease development. The thioflavin t-test is a widely used tool for studying and quantifying A-beta aggregation and inhibition. Today, we'll discuss the significance of A-beta aggregation in Alzheimer's disease, the THT assay for studying A-beta inhibitors, and their possible therapeutic implications. Let's talk about A-beta aggregation. Beta secretase and gamma secretase sequentially cleave to amyloid precursor protein APP to produce A-beta peptides. A-beta monomers can organize into oligomers, protofibrils, and matrofibrils, forming plaques in the brain. These plaques cause neuronal damage, inflammation, and disruption of cellular function, all of which contribute to Alzheimer's disease symptoms. Extensive research has been conducted to identify possible inhibitors of A-beta aggregation with the hope of alleviating AD symptoms. These inhibitors suppress the development of hazardous A-beta species, stabilize non-toxic forms, and facilitate the clearance of aggregates. Next up is the thioflavin T assay. The THT assay is a popular technique for detecting and quantifying the production of amyloid fibrils. THT is a benzothiazole dye that fluoresces more when bound to the beta sheet-rich structures of amyloid fibrils. This fluorescence can be monitored with a spectrophotometer, offering a quantitative way to track fibril production over time. In the assay, A-beta peptides are incubated with THT, either with or without inhibitors. The intensity of fluorescence increases in proportion to the degree of fibril production. By comparing the fluorescence in samples with and without inhibitors, researchers can assess the efficacy of the inhibitors in preventing A-beta aggregation. Now let me provide you with some experimental evidence for the inhibition of A-beta aggregation. Various compounds, including small molecules and peptides, have been tested for the capacity to suppress A-beta aggregation. Here, I present examples of such inhibitors and evaluate them using the THT assay. Small molecules such as curcumin, a natural polyphenol in turmeric, have been demonstrated to reduce A-beta aggregation. Curcumin significantly reduced THT fluorescence in THT experiments, indicating decreased fibril production. Besides, peptide inhibitors were also evaluated. Peptides that imitate portions of the A-beta sequence can decrease aggregation. The peptide KLVFF inhibits A-beta aggregation by attaching to the same sequence in A-beta monomers. THT assays showed that KLVFF-treated samples had considerably lower fluorescence than controls. Before we wrap this up, I want to discuss the therapeutic expectations and challenges of this finding. Inhibiting A-beta aggregation has promise as a treatment for Alzheimer's disease. Effective inhibitors could potentially delay or stop disease development, resulting in significant therapeutic benefits. However, transferring these discoveries from in vitro testing to clinical applications poses significant hurdles. First, bioavailability and pharmacokinetics. Many promising inhibitors are poorly bioavailable and stable in vivo. Effective delivery techniques must be devised to ensure that these substances reach the brain in enough concentrations. Toxicity and side effects are also important to consider. Some inhibitors may cause off-target effects or toxicity at greater doses. Comprehensive toxicity studies are required to ensure the safety of these compounds. Don't overlook the disease complexity. Alzheimer's disease is complex, with A-beta aggregation being only one element of the pathogenesis. Combination medicines that target many pathways may be required to obtain significant clinical benefits. Last but not least, clinical trials. Large-scale, long-term clinical trials are required to validate the efficacy and safety of A-beta aggregation inhibitors. These trials are costly and time-consuming, creating a significant barrier to medication development. Finally, the conclusion. The THT assay helps find and characterize inhibitors of A-beta aggregation, providing a quantifiable measure of efficacy. The positive results from various substances, including small molecules and peptides, raise hopes for the development of effective Alzheimer's disease treatments. However, there are major obstacles to integrating these findings into clinical practice. To fully use the therapeutic promise of A-beta aggregation inhibitors in Alzheimer's disease, further research and development, as well as creative delivery and combination approaches are required. These are the references I used while researching for this presentation. And please let me know if you have any questions, or feel free to contact me anytime later. Thanks a lot for listening to my presentation. I hope you have a wonderful day.